Hello once again. Welcome to the video of introducing Google Kubernetes Engine. Here I'm going to highlight some core features of Google Kubernetes Engine. Google Kubernetes Engine provides a managed environment for deploying, managing and scaling containerized applications using Google infrastructure. The Kubernetes Engine environment consists of multiple virtual machines, also known as Google Compute Engine Instance. And these virtual machines are grouped together to form a cluster. In this video, we will make our hands dirty with container creation and application deployment with Google Kubernetes Engine. Before we move into Google Kubernetes Engine, let's try to understand what Kubernetes is from a very high level. Kubernetes provides the mechanisms through which we can interact with our cluster. We can use Kubernetes commands and resources to deploy and manage our applications, perform administration tasks, and set policies, and monitor the health of our deployed workloads. Kubernetes draws on the same design principles that run popular Google services and provides the same benefits like monitoring application containers, automatic scaling, rolling updates, and many more. When we run our applications on a Kubernetes cluster, you're actually using the technology based on Google's years of experience running production workloads in containers. When we run a Kubernetes cluster in Google Cloud Platform, we also gain the benefit of advanced cluster management features that Google Cloud Platform provides, such as load balancing for compute engine instances, auto scaling, logging and monitoring, and so on. So, I tried to give you a basic idea of Kubernetes and Google Kubernetes Engine. Now, we shall get to know how to deploy a containerized application with Kubernetes Engine in the shortest possible time. First of all, we need to set our compute zone to US Central 1A. You can choose other compute zones if you want. Compute zone is a regional location in which the cluster and its resources will live. To set our compute zone to US Central 1A, start a new session in the Cloud shell and run the gcloud config set command to make US Central 1A as a compute zone. Now, we are going to create a Kubernetes cluster. A Kubernetes cluster must consist of at least one master node and multiple worker nodes. Here, nodes are just another compute engine instance that run the Kubernetes process to make them part of the cluster. To create a cluster from the shell, run gcloud container clusters create command, followed by the name of the cluster, which is, say for example, my cluster. You can give any other names as you wish. If we press enter, then it might take a few minutes to finish creating the cluster. Once the cluster creation is completed, you will get an output like this. So, we have successfully created a Kubernetes cluster. Now, how to access into that cluster? Well, after creating the cluster, we need to first get authentication credentials to interact with the cluster. Authentication credentials can be retrieved with gcloud container cluster get credentials command, followed by the cluster name that we provided during the time of cluster creation process, and then press enter. We should get an output like this. That means we have been successfully accessed and authenticated into the cluster we just created. Now, the main part of this video, deploying a containerized application to this cluster. Basically, Kubernetes Engine uses Kubernetes objects to create and manage the cluster's resources. For example, Kubernetes provides the deployment object for deploying stateless applications like web servers, service objects for defining rules, and load balancing for accessing the application from the outside world. In this video, we are going to deploy an Nginx web server as a containerized application, and to deploy this Nginx web server in the cluster, run kubectl create deployment command, Give the deployment a name such as web server and then mention the image to be used to deploy this web server, which is Nginx with version 1.10. If everything is okay, then press enter. So, Kubernetes has created a deployment. I will talk more about deployments in another video. But for now, all you need to know is that deployments keep the pods up and running even when the nodes they run on fail. In Kubernetes, all containers run in a pod. We can execute kubectl get pods command to see what pods are running in the cluster. If we provide option wide, then we can also see on which nodes the pods are running. So we can see the Nginx container is running, but this Nginx web server is still not accessible by the outside world. To make it accessible by the outside world, we need to create a service by exposing the deployment object. And to do this, execute in the shell kubectl expose deployment command. This command mentions which deployment to expose and which port to be used by the outside world to access the web server. Then press enter. As soon as you pressed enter, behind the scenes, Kubernetes created an external load balancer with a public IP address attached to it. Any client who hits that public IP address, followed by the port number we mentioned in the previous command, will be routed to the Nginx web server that is running behind the service. We can check the details of the services, including the public IP address, with kubectl get services command. It might take a few moments to provision the public IP address. If you still see the public IP address is in pending state, then execute the same kubectl get services command until the public IP address is visible. So, this is the IP address the web server can be accessible with. Copy the IP address and then paste it into the browser, press enter. If you see a page like this, then congratulations! You have successfully deployed a containerized application into Google Kubernetes Engine. That's all about this video. Before we move into the next video, destroy the cluster you created with container cluster delete command. When prompted, type Y to confirm. Deleting the cluster will take a few minutes. In the following video, we will deep dive into the details of provisioning a complete Kubernetes cluster using Google Kubernetes Engine.